Kubernetes is one of the most popular choices today for managing containerized applications. In this video, I'll introduce you to Kubernetes and show you how to use it. Here's what you'll see in the video. A Kubernetes overview. We'll install the requisite software, including Docker, Virtualbox, Node.js, and Minikube. Then I'll show you how to work with the Kubernetes application, first by creating a containerized application, deploying the application to Minikube, and then managing the application with Kubectl and the Kubernetes dashboard web UI. If you already have the software installed and want to jump right into working with Kubernetes, you can skip to this time mark in the video. Let's get started. Kubernetes is an open source system for automating deployment, scaling, and management of containerized applications. But what does that mean, and how do you use it? To answer that, let's start with an overview of Kubernetes. First, let's ask the question, why containers? To answer that, let's visit the Kubernetes documentation. Before containers, we installed applications directly on the target host, along with any libraries the applications needed, plus libraries needed by other applications as well. This is host-centric infrastructure. At best, it presents DevOps with maintenance challenges, and at worst, integration conflicts between applications, versions of applications, and so on can lead to poor performance and even downtime. With containers, on the other hand, all the applications run in their own isolated mini-environments, away from each other and the underlying OS. This is container-centric infrastructure. Now I'd like to go over some basic Kubernetes terminology, beginning with the pod. A pod is where an application is deployed and contains resources specific to an application, such as file storage. Pods can contain multiple applications, and all applications in a pod share the same IP address and port space. Think of a pod as the logical host and as the atomic unit of deployment and scheduling in a Kubernetes cluster. Next up is the node. A node is a physical or virtual machine in the cluster and runs one or more pods. Each running pod with the same definition is called a replica, and a pod can be instantiated more than once to improve application scalability within the cluster. Speaking of the cluster, the Kubernetes cluster is made up of one or more nodes, along with a special component called the master that's responsible for scheduling and maintaining the desired state of the cluster. The job of Kubernetes, specifically the master, is to maintain the desired state of the cluster at all times. But what is the desired state? Again, we consult the documentation. The desired state is defined as the applications and workloads you want to run, what container images to use, the number of pod replicas, and other stuff like network and disk resources that your applications need. The master compares the current state of the cluster to the desired state, and if they differ, makes any necessary adjustments until the desired state is once again reached. This is helpful for, say, when an application crashes. The master will detect the application is no longer running and restart it. Now the cluster is back to the desired state. Now you know what Kubernetes does, it's time to use it. But first we need to install some software. This video shows the installation for Mac OS, but for each piece of software, I'll show you the installation page, which also contains instructions for Linux and Windows. And be sure to check the video description for all those links as well. Let's install some software. To install Docker, go to the installation page. Scroll down until you see your platform, which is Mac OS in my case, so I'll click on Docker for Mac OS. I want the distribution from the stable channel, so I click on the link that says Get Docker for Mac Stable. Always verify the 256-bit SHA checksum of the downloaded file matches what is published. Now double-click the DMG file to begin the installation and follow the instructions. For more information, go to the installation page. Minikube requires a virtualization environment in order to run. For this video, I'll use Virtualbox. If you want to use different software, check out the Getting Started with Minikube page at kubernetes.io. To install Virtualbox, go to the Virtualbox installation page and click on the link that matches your platform. Verify this SHA-256 checksum matches the downloaded file Now double-click the DMG file to begin the installation and follow the instructions. For more information, go to the installation page. In order to test the demo application, you'll need Node.js installed. I already have Node.js installed on my Mac, so I'll skip that for the video. Make sure to check out the Node.js installation page. Click on the download link that matches your platform and follow the instructions. The final piece of software you need is Kubernetes. In order to run it locally on your machine, the folks at Kubernetes recommend you use Minikube. Quick note here, keep in mind that Minikube is a tool for running a Kubernetes cluster locally. For our purposes, Minikube is Kubernetes. So I'll refer to Minikube and Kubernetes synonymously in this video. Go to the Minikube page at GitHub and look for installation. I like to use Homebrew to install software on my Mac. If you're using Linux or Windows, the Minikube installation page has instructions for those platforms as well. Drop out to a terminal window and execute the brew cask install for Minikube. Homebrew installs Minikube, and now it's ready to go. So you're finally ready to start using Kubernetes. The first step to deploying a containerized application is, well, the application. I put together some demo JavaScript code that you'll run as a Node.js application. Open a terminal window or command prompt, navigate to a location on your computer where you want the code to land, and clone the code from GitHub. Git clone https github.com Makoto Go Developer Works. Navigate to the Kubernetes directory and take a look at the JavaScript code. This toy application doesn't do anything serious, it just outputs a message to the console, but that's enough for our purposes here. Now run the application in Node. Open a browser and point it to localhost port 8080 to see the message. And there it is. Now you have an application, it's time to containerize it. Here's how you use Docker to do that. Take a look at the Docker file. Use this Docker definition to containerize the application. But before we do that, we need to start Minikube, and I'll show you why in a minute. Execute the Minikube start command. The first time Minikube runs, it has to download the ISO image to run inside Virtualbox, and may take a minute or two depending on the speed of your internet connection. Once the image has been downloaded, Minikube will start. Minikube runs inside Virtualbox in its own VM, or virtual machine. We need to make sure that Docker uses the internal registry on Minikube's VM by executing this command. Eval space $ open paren Minikube space docker-env close paren. Otherwise, Docker will use the local registry on your machine, which is not accessible from the VM where Minikube is running. Now, from the terminal window, execute the docker build command. Docker space build space -t space k8sdemo v1 space period. This will create the image with a name of k8sdemo and a tag of v1 and store it in the Docker registry of the Minikube host VM. When deploying the image to Minikube, you'll reference that tag explicitly. So, let's review. You've installed the requisite software, you've tested and containerized an application, and you've started your local Kubernetes cluster, Minikube. Now it's time to deploy the containerized application to Minikube. From the terminal window, execute the kubectl run command. Kubectl run k8sdemo --image equals k8sdemo v1 space --port equals 8080. And now the application is running in its own pod. Not very exciting, is it? Okay, so remember from earlier how a pod is like a mini host, complete with its own IP address and port space? When Kubernetes starts a pod, it's isolated in its own network. So how do we interact with the application? One way is through a proxy, which you can start in a separate terminal window. Start a new terminal window and execute the kubectl proxy command. Kubectl space proxy. By default, the proxy uses port 8001, but you can specify a different port using the --port option. kubectl proxy -- port equals 8080. This starts the proxy using port 8080. Now you can connect to the cluster through port 8080 on your computer. I've written a script to get the pod name and use it to access the application through the cluster's REST interface. The script is called test-k8sdemo.sh and takes the port as an argument. And there you see the output. Now that we have Minikube up and running, let's talk about how to manage it. You can use the kubectl command to get information about pods, deployments, and so on. For example, you can show a listing of the deployments or of the pods. You can even get detailed information about the pods. Now, I love the command line as much as anybody, but did you know that Kubernetes has a web-based UI dashboard? By default, the dashboard is not deployed. From the documentation, you can copy the command to create the deployment through the kubectl create command. Paste that into the console to deploy it. Make sure the proxy is running. This time I started the proxy on port 8001. Once the dashboard is deployed, you can access it from localhost port 8001/UI. You can see the same basic information as from the various kubectl commands, but in a UI. That's how you run a Kubernetes cluster using Minikube. Now your computer's set up to do some serious Kubernetes development. I hope you enjoyed the video. I'm Steve Perry, and thanks for watching.